Okay, so today is more difficult combination questions. And the first thing you have to ask yourself is, does the order matter? Let me give you an example. Okay, if the order matters, I have to do a P. So if I have order not mattering, I have to do a C. So if I were to say I'm making a committee and I need 3 people to be on the committee. Okay, so let's say, imagine for a moment we're gonna have a party in here on the last day, and I needed 3 people to like organize it so that somebody like brings cups and somebody is like rounds up people to bring some food. And is this real? Could we? I suppose we could make it real. But I'm just saying, if we were gonna have a committee, do you get that that does not require like rigid placements order? Like it could be you 3 and it doesn't have to be in that order. Okay, so that would be a C or a P? That'd be a C. If the order matters, it'd be more like, I'm going to arrange the books on a shelf. And the number of ways you can arrange them is mind-boggling. I have on my wall 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 posters slash things on my wall. Oh, 17, I guess. That one's kind of wimpy, but the rest of them are plain. But I want to go with 16 framed posters on my wall. How many different ways could I arrange them? Does that imply order? Yes, and that's a common mistake to think it doesn't. But it requires order, because if I don't care what order they're in, then I'm done. They're already up, and I've already chosen them, and there's no question to be asked. If the order doesn't matter, what are you asking? So if they're asking how many different ways can I arrange my posters, I'd like you to figure that one out. I got 16 posters. And assuming, I know there's a lot of assumptions in the real world, but assuming that I can actually hang any poster in any spot, which isn't necessarily true, but imagine I could. Is that a P question? Yes, and I have 16 posters, and I have 16 spots on my wall, so it's what? 16P16. Good. I actually, though, have more, because I have this one over here, 17, and this one right here, 18, 19, 20, 21, 22, 23, 24, 25. I have 25 posters and 16 spots on my wall. All right, so what was 16P16, first of all? There's a, what? Okay, hold on. Was that the 25 or was that the 16? 16P16. Times 10 to the what? 13. Holy smokes. All right. That is a lot of different ways that I could arrange my posters. Not many people would have said that. You would have guessed that there was maybe 1,000 ways, maybe. And it's actually like, what is it, a trillion? 20 trillion? Okay. It does not seem possible. I get it. But how about if I do it this way? There's 16 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 spots on my wall. How many choices do I have for the first spot? 16. And it just keeps going down by 1. If you know this one, it's called 16 what? Factorial. You could actually do it that way. There's a button on your calculator. You go 16, and then you say exclamation mark, which is under math, PRB. Try it once. I bet you get the same answer. Yes. Yes, you may. Was it the same answer? All right, good. Okay, so since I actually have 25 posters, and I'm choosing out 16 spots on my wall. Was it 25? Is that what I said before? Yeah. Okay, good. Would you figure out that one, please? And it's a ridiculously large number, of course. It gets even more insane. Yes, sir. Why did it change from... Oh, thank you. Thank you. It's not supposed to be C. It's supposed to be P, and I think you probably did P because you knew that, but I said P. Thanks for fixing it for me. This is supposed to be P. All right. 25P16 means there's 25 times 24 times 23, but it's not 25 factorial because you run out of blanks at the end. That's why you need to do this p thing. Otherwise, you could just do everything with factorials. It can be, because this p thing is really 25 factorial over 25 minus 16, which is 9 factorial. And then the p's, you don't do the extra thing on the bottom, so this is done. 25 factorial divided by 9 factorial. Anyway, that would have also worked, but either way, ridiculously large number. My point is just that arrangements, when they say I'm going to arrange something, listen, if I'm going to arrange something, does order matter? Yes. Arranging it means rearranging it, implies rearranging it, and that means the order matters. Okay, so that's P. All right, let's move on to this kind of question. Oh, sure, what's the answer for that? 0.7, so I'm going to go like this. Okay, let me think. Million, billion, trillion, so I need 3 more zeros? Did I do that right now?
No, that's quadrillion.
Quadrillion. Oh, I need 3 more zeros? Holy smokes. Okay, that's how many ways I could rearrange my posters. Yeah, if I start rearranging now, like seriously, it would be more than my entire lifetime for the rest of my life without breaks for bathroom or eating or sleeping, and I still couldn't do it in my lifetime, or maybe even in 3 more lifetimes after that. Anyway, you could actually figure that out if you figured out how long it takes you to change each poster out. But, yep. All right. Keep rotating them. Well, I'm on arrangement number 72. Oh, you get a little sick of that after a while, I think. Okay, so this is mainly about getting to these combination questions, and this is important to understand. Whenever we do food things, we don't say the order matters. I know you could argue that on pizza you want it in a certain order because you like it that way or whatever, but we're just going to say there's no order mattering on pizza or cards. Because also, again, I know in some games of cards, it does matter what order you got your cards in. But if I deal you 5 cards, and you 5 cards, and you 5 cards, and you pick them up all at once, you don't even probably remember which card you got first if you pick them up all at once. So we're going to think of it as the order doesn't matter. So for the rest of the day today, all these problems are going to be C questions because the order doesn't matter. And I want to tell you ahead of time that a lot of them are either this way, CC, or this way, CC over C. Which of those, and these are all multiplies, except for that, of course, means divide. Which of those means a probability? This one is a probability because it's got a fraction, right? So wait for the problem to say, what's the probability that, and then you have to divide like this. It'll be one of these. Otherwise, it's just going to be something C, something like 2C3. That could actually never happen. 8, 3C3, 10, C2, that kind of thing. That's the only thing you have to do, unless they say a probability, in which case you have to have another C on the bottom. So just so you get the framework, that's what the kind of problems are like today, is CC or CC over C. We're going to talk about Chipotle, which has a great big C in it. And I'm not going to record this next part, but I'm going to tell you, I've got a math behind it on this, on how to get the biggest burrito. So I'm going to pause. All right, here we go. We're back from the math behind it thing. Showed them how to get an 89% bigger burrito. Was 84 or 89? 86. I averaged them apparently. Okay, 86% bigger burrito. That's what it says in the article. So back to, what do we do when we just want how many different toppings there are? Does that say the word probability in it anywhere? No, so then it's just a CC kind of question. And in this case, it's really simple. All of these, which I added them up already, is 11 toppings that you could get. Now, I made this, actually, I didn't make this slide, but somebody made this slide a few years ago based on their website. This is the toppings they offered a couple of years ago. I don't know. Is there any that have changed? It's been pretty much the same. Yeah, you're right. Brown rice isn't up there. Awesome. All right, so there's more, but for right now I'm going to leave it just so that my answer will stay the same over here behind there. So It is. There are 11 toppings, and I get to choose how many for each? 2. There we go, 11C2. I didn't need the extra C. Sometimes you don't, but a lot of times today you do. As they get more complicated, you'll need 2 separate C's, and I'll show you why. If there's 3 toppings, it's just 11C3. Don't overthink that. Okay, any questions on that? All right, moving on to the next one. At the Price family reunion every year, a group of 3 is chosen to plan next year's reunion. That makes some sense. These are the people who are going to be at the reunion, so you let them, there's going to be 3 people that plan the next one. Any you guys have big family reunions like that? Yeah, there's a bunch of you. Okay, cool. Our family gets together, but it's just, even just with my brother's family and my 2 sisters, we used to have 39 of us when we got together. Now it's up to like 42 because babies keep being born and stuff. So anyway, but I know some families it's just ridiculous. They're like talking hundreds. I knew a guy from Saudi Arabia who stayed with us for a while, and his immediate family, just him, and because in his family, his father had 4 wives, of which all had many children, and then you do that, plus his father's brother was the same. When they have family reunions, we're talking hundreds of people get together, and that's just like the close relations, not the like far away ones. So anyway, it was a really eye-opening experience. All right, so anyway, these guys have 9 people in attendance at this year's reunion, but 3 of them planned this year's reunion. So do you get, we don't do 9C3, we do 6C3. Does that make sense? All right. So this one is where we start getting them a little more complicated, because we don't just have 9 people at the reunion. We have them divided into subgroups. We got 6 with chocolate chip, 5 with peanut butter, and 1 oatmeal. Together, that makes 12 cookies. They're all on a big plate, okay? You've probably been to family reunions like that where they have the big plate of cookies and there's different kinds on there, okay? If you just randomly pick a couple, you're not even looking, you just like grab a couple off of there, what's the probability you'll get this or that? Well, right now, find the probability that he selected 2 chocolate chip cookies. That's a probability. Remember me saying we have to divide by something then? This is the most complicated kind where it's CC over C. In fact, I could even make a good argument that it's CCC over C. Write this down with me and let's see if you can understand how this works. The first one, everybody write a little CC for chocolate chip. The next one, write PB above it. And the last one, write an O above it. What's that for? Oatmeal. Good. How many are there? How many do we want? How many are there? How many do we want? Do you get what I'm doing here? How many chocolate chip are there? 6. How many do we want in this scenario? It says 2 chocolate chip cookies. How many peanut butter are there? 5. How many do we want to get in this scenario here? We don't want any of those. 0. And you might think that'll mess up our problem to have a C0. It doesn't. It actually just equals 1 then, that part. And the last one is oatmeals. There's 1 oatmeal, and we don't want any in this scenario. Now, you might just say to yourself, Mr. Server, why didn't we just do 6C2? It's because, let me show you how this thing balances so perfectly when we're done. At the end, you have to divide by something, and what you divide by is what all of these things add up to, which is there were 12 cookies. See how that balance is nice? 6 plus 5 plus 1 equals 12. And then 2 plus 0 means we took 2. So we had 12 total cookies, of which we chose 2. And this is all the things that were possible to happen. Out of the 12, we picked 2. Then on top, we have what we want to happen, which was we would get 6 choose 2, and we'd have 5 of this kind choose 0, and 1 choose 0. Do you get how all the red circles add up to 2, and all the black circles will add up to the 12? That's how they're supposed to balance. And then all you got to do is type that in your calculator. But if you're smart about it, you will skip these, because if they're choosing 0, they'll just equal 1 when you do them. You'll save a lot of time by not entering that or that on your calculator. And you just do 6C2 divided by 12C2. But I still contend you should set it up the way I showed you so that it balances. I don't think I've ever seen a kid set it up so it balances and then get it wrong. Usually people, if they get the problem wrong, it's because they didn't set up the top right. Okay, you saw me do that one. You do the bottom one, CC over C. Actually, there's 3 kinds, so it's CCC over C. Pause for a second while you try that. I got a good question. I was asked about those C's and whether you ever add them. I know there were problems before where we were adding things on top, but those weren't choices. You multiply choices. So we were always with C's like this. I cannot think of a situation where you'd ever add them. You would multiply your C, your combinations. So like this is times that is times that. I'll pause while you continue to figure that one out. All right, we're back, and these were the chocolate chip. It could have been any order you want, but I'm going to make that the chocolate chip. There were 6 of them. How many did we want to choose? 1. There were 5 peanut butter, and we wanted to choose how many peanut butter? 1. And then this last part is kind of optional, but I'm telling you, more kids get them right when they do this part, because the problems where we're going to, it's easy to forget something at the end. All right, so anyway, there's 1 oatmeal, and you want to choose 0. Then that makes it add up perfectly so that there's a total of 12 cookies choosing to 5, 6, 1 adds up to 12, and 1, 1, 0 adds up to 2. If you set that up right, then you're going to get it right. How many of you had it set up right? Cool, that's the hardest kind that there is. All right. Now, this one, notice it's not a probability again. So we're not dividing. So it's just going to be CC. In this case, when it's as simple as this, there's 5 cards being dealt out of 52. You only need 1 C for that. And it's 52, what? C5. That's it. Wait a minute. This next one's a little more complicated. Right away, you just go to 2 C's. Okay, now we're doing subgroups out of that 52 cards. The hearts and the diamonds. Here's hearts, here's diamonds. Okay, and the hearts, there's how many hearts? 13. How many do we want? 4, because it says 4 hearts. How many diamonds are there in the deck? 13. And how many diamonds do we want? Sorry, how many do we want? We want 1. Good. And I could stop right there, and it wouldn't hurt. It would actually be right. But do you get how you could also make an argument that there's 13 spades? I don't know how to draw a spade. They're pointy on the top. Anyway, 13, and I get 0. And then the last one is clubs. That more looks like a clover. I've never really understood. It looks like a clover. They call it a club. Anyway, and it's 13. Of those, choose 0. Why do those not matter? Because when you times by them, they're both equal to 1 anyway. So timesing by 1 and timesing by 1 doesn't really matter. When it's not CC over C, you don't need those as much. But I still think it's good thinking. All right, find the number of 5-card hands with exactly 2 queens. Didn't say the word probability, so I don't need to divide. I just do this kind of a thing. Now here's where if you just write, okay, there's 52 cards in there, and I'm going to choose 2 queens. I'm doing something tragically wrong. How many? 4? There's 4 queens. Very good. And I want how many of them? But if I stop right there, I'm doing something tragically wrong because I've only got 2 cards. How many cards am I supposed to have? 5. Am I supposed to just guess what the other cards are then? No. And this is where if you did 4 C's, it would actually be too hard because you wouldn't know which one you got. Like we got 2 queens and then I got 3 more cards coming. What am I going to get, 1 of each? Doesn't say that. So what you do is something kind of genius. You put them all together and say these are queens and these are not queens. And it's still a CC question. So it's just queens, not queens. There's 4 queens, choose 2, and there is 48 not queens. And you're going to choose 3 of those. That is one of the other hardest problems that there is on today's lesson. Okay. So that brings me to something that I feel like I should warn you about. This question is one of the hardest. As I've graded many of these tests over the years, this is the one that kids get wrong more than any other. And it has to do with defective. And here's the trap that people fall into. They go, okay, I get there's 120 phones, and there's 18 of them are defective or damaged. But then they use 120 in their problem, and they use 18 in their problem. And it'll be wrong. Let me show you why. It does say probability, so right away it's CC over C. You gotta don't forget to not divide by C. All right? Then what are my 2 things? Are we talking hearts and diamonds here? No. What are my 2 things, my subgroups? Broken and not. Good. These are broken. I'm going to call these new. They were both new, but maybe I should say not broken. Or how about work? Broken and working. All right. And guess what people do? No, not 120 broken ones, because it says right there, 18 were damaged. So they go 18 brokens and 120 working. You get how that's messed up? Okay. If it's 18 broken, then how many were working? 102. Very good. So watch out for that. Okay, next is, of the broken phones, how many do we get? I know this is what we want. We don't really want to get a broken phone, but we want to investigate out of 4 iPhones, the probability that 1 of them is defective. So 1 defective one, and 3 working. And then how do you do the bottom? You add up the other ones, yeah. How many total were there? 120. And how many phones total did we get? There we go. And this plus this should equal that. And that plus that should equal that. Does that make sense? All right. That's the hardest one, and you saw, I think, where people were making their mistake on that. So be careful with that kind. I think there's one in your homework like this tonight, so be careful with it. All right, and tonight's homework. I will pause for a second while I pull that up. All right, I've got it pulled up here, and I can tell you that we do a lot of questions like 1 and 2, and therefore I think you should do all of 1 and all of 2. And they are, if they don't say probability, which number 1 and number 2 doesn't, if they're not probabilities, they're just CC. If they were probabilities, it would be CC over C. Remember, probability comes in when you're dividing. All right. Then you go on to number 3. And on this one, I feel like this gets just a little bit redundant, so I'm fine with you skipping D, E, and F on problem 3. You can skip D, donkey, elephant, foot, D, E, F. And we do a lot of card problems, so we really shouldn't skip number 4. And then this very last one, number 5, I think it's a good thinking question, even though you can do it in the calculator, totally. Just go ahead and do that in the calculator. You'll get 2 answers. And then I want you to think about what it means. You have 100 people or things you're choosing from, and you choose out 3 at a time versus choosing out 97 at a time. And the weird thing is that they come out, what? The same. And I want you to think about why that is. If I choose out this 3, isn't it kind of like I chose out that 97? When I take out 3 of them, aren't I effectively taking out 97 because on the one side there's the 3 I picked, and then the other side there's a 97 I didn't pick. So I'll let you figure out like how to say that. So, all right. And that's all I have for you for today.